Here we are. So in WeatherXM, what essentially we do is we utilize a dense network of weather stations, devices like this one, that community deploys, and we try to provide the most accurate weather forecast service possible for the customer's exact location. So most of the worldwide economy is weather sensitive, and these are just two examples. In agriculture and energy, there are tens of billions to be saved from wrong operations and resource wastes, and by having a slightly better weather forecast, which depends very much on the actual weather data. And because there's not enough weather data, the forecasts are not very good. And weather data are produced primarily by ground stations, the satellites and airplanes and so on, but ground stations are really important because these are the data that are used to calibrate all the others. And weather stations typically are expensive, they're complex to deploy, they're limited by a number of factors, and we have given the governments the role to usually deploy those. So as you can imagine, they're doing a very inefficient job here. So we believe a new approach is needed for a global impact, and we are inspired by Filecoin and Helium, and we have designed a new economic model for deploying weather infrastructure. So in our model, we use our native token, crypto rewards, in exchange for the weather data that the community generates, the weather station owners generate, and we ask our customers to buy and spend those tokens in exchange for weather services and raw weather data. And to support this model, we had to create our own hardware. This device is one of the 3 devices that we have, 3 types of hardware that we have, and it's designed specifically to be rolled out in large quantities. So to make it as easy, as simple as possible for community members to deploy it. And it's energy and communication autonomous. So that means you just put 2 batteries, it has a solar panel, you just put it out there and magically works, doesn't need anything. This particular one connects to the Helium network. But the most important aspect of it is we added a crypto chip that signs the payload from the GPS and from the sensors. So we essentially have cryptographic proofs about weather conditions and proof of device and proof of location on chain. So we also have a Wi-Fi device and a LTE, GSM device, and we're going to launch more hardware this year. So we are iterating very quickly on hardware, and I think this is really important for our project because the state of the industry is quite old. The stations are quite cumbersome, the traditional ones, I mean. And we also have a mobile app that our users can use, and you can actually install yourselves, that you can see historical real-time and very accurate forecasts for the locations that we have stations around the world. So if you're lucky to have one of our stations in your area, you can benefit from this for free. And we have shipped a lot of hardware, more than 7,000 devices already. And we're not even on mainnet. So we have a token, but we've been on testnet forever. And we've built a network of 4.6 thousand stations in more than 80 countries. And obviously, the rewards that we give to our community, to the weather station owners, they are not like airdrop of a meme weather token. They're based on the quality of data they produce. And the interesting part here is that if you compare our network to NOAA's, our quality of data is way, way higher than what the government network is. And if you try to download the data from NOAA's weather stations, roughly 50% of this data is missing because the stations are offline. And in our case, we have more than 80% of our weather stations in pristine condition because we have created a number of novel algorithms that we try to detect if the station has been deployed properly, if it has any obstacles near it that is blocking its sensors. We can detect a number of different things by looking at the time series data. And we call this quality of data, and it's the most important aspect of the reward mechanism that we use in our network. So we haven't launched our B2B side of things yet, but we have traction from customers. We're doing a lot of pilots from energy companies in California up to shipping companies from China. And we are also very active in the public goods space. We are collaborating with EthicHub. We are donating weather stations that are deployed in farmers in Mexico. Obviously, the global south lacks weather infrastructure the most, so they immediately benefit the most from improved weather forecasts. And one of the services that we can provide very easily by having additional weather data is what we call quality of forecast and mosaic forecast, which is basically a hyperlocal forecast that is built on top of third-party forecasts and the ground station data. So what we do, we are not claiming that we can compete with NOAA. NOAA operates on a $7 billion annual budget, and they actually spend $1.2 billion just to maintain their weather infrastructure for those 13,000 stations. So huge waste of money. But anyway, but they do a global forecast, and that's not easy. So they do a global simulation of Earth. They use supercomputers. They're using super old legacy Fortran code, but that's another problem. And yeah, so we input those forecasts from NOAA, from the European agencies, from multiple meteorological companies, global ones, that they have different models, therefore produce different forecasts. So those forecasts are contradicting each other. And we use our ground station to detect which forecast is the best for that location per element and day ahead. And we create this mosaic or this synthetic forecast, basically, that is more accurate than any of the other ones. And we can prove this on-chain, on Filecoin. All the data we use are open. And basically, this is a huge tool to convince our customers that our service is superior. Marla, how am I doing on time? Should I go into? Awesome. So I have a small demo here. I wasn't brave enough to do it live, so I have a few slides. So this is a portion of the infrastructure, the cloud infrastructure we have, which relates to data management. And as you can see, unfortunately, a huge chunk of it is in AWS. So I think, especially in different projects, it's really difficult to decentralize the whole thing and make it like a protocol. So in our case, we're using a lot of AWS infrastructure to transform data and to calculate this quality of data that I mentioned before, and therefore finalize like how many rewards each station should get. And that's not cool for the crypto world. In my point of view, it shouldn't be that way. So with the help of Tableland and Filecoin, we have a parallel stream where we export the data to decentralized infrastructure, and we are doing the same calculations again. We are providing mechanisms for anyone in the community to validate that the rewards that we're giving are actually the ones that we should. We're using another project of the Protocol Labs ecosystem that is called Bacalao, Compute on Data, which is another super cool project. And with this computation power, we can retrieve data from Filecoin and do all this fancy stuff. So I'm just going to very briefly show you how this looks like if you try to do it. So it's just 3 simple steps. Step number 1, you go to our Intex website, the network website that has all the data, because we export all the data of the project on a daily basis. You select the day that you want to use, then you select the Docker container of the quality of data algorithm that the latest one that we have published. You fetch the rewards, you execute, you send a job to Bacalao with the data, and then you fetch the rewards. So this looks something like this. We have a GUI there that is also hosted on IPFS. You can select or download your Parquet files, S3 large files of the network. And then you execute a command, a Bacalao command, which is like a Docker execution that you specify which data set you want to use, what is the name of the station you want to calculate the quality of data 4, and a number of other parameters. And what's interesting with this is that in a couple of seconds, you will get this score calculation back by using only 12 cores and 32 gigabytes of RAM. And that's for one station. And we have 4,500 stations. So that's really expensive to do on AWS. So the sooner we get rid of AWS, the better it will be for everybody. So once that happens, what you get is a very detailed JSON file that explains how what was the quality of data per element through a bunch of detection mechanisms that we have, classifications and so on. And you also get some pretty looking, well, at least for scientists, plots that they give you a sense of, it's like a sanity check for humans to make sure that this is not just crap. And the same results are made available in IPFS, so you can connect to them and process them further on. Yeah, so I think like we have a lot of work ahead of us in order to completely decentralize our project, but we're actually doing some great progress. And it's really, I feel like I'm really excited that we're working on a project that is one of the most challenging ones for humankind.